Hi, ladies and gentlemen. Mr. Guy here, going to talk about a different kind of system that we can solve. So basically, still following the same concepts of what you were doing, what you're going to be doing the first couple days of this week, Tuesday, Wednesday. I want you to do on Thursday and Friday. But in this case, it's going to be those four problems I told you to leave alone, where you're going to get either infinite or no solutions. And basically, those are going to come about the exact same sort of way. So I'm going to kind of show you an example of how that could show up and kind of what your response should be when it does happen. Okay, so here's kind of the deal. What you're going to be doing is you're going to be solving these systems exactly how you were before. So nothing about that's going to change. You're still going to be looking to eliminate different variables until you have it broken down to where you have three variables, then two, then one. So looking at, here's a system here that I'm going to go ahead and I'm going to solve. I can see already that this line right here, I have y missing already, which is a nice start for me. Because I see y is missing, I'm going to go ahead and try to eliminate y from one of these two, and then I'll go ahead and eliminate one of the other variables as I go. I'm going to start by getting rid of y. So what I'm going to do is I'm going to multiply this third row by 5, and then I'll go ahead and add that to the first row. So we'll kind of do one step at a time here. We'll multiply this third row by 5. So the first thing I'm going to do is rewrite all the other rows, and then I'll rewrite the third row multiplied by 5. I'm going to pause the video here. I'll come back with this fully written out, and then we'll kind of move on to the next step. All right, so magic of time travel, probably just a couple seconds for you, but I went ahead and rewrote this whole thing, multiplying that third equation by 5. And the reason why I did that is because now you can see that y's both have the same number in front of them. This one is a -5, this one a +5. So if I combine the first and third row together, the y is going to go ahead and disappear. So I'm going to do row 1 plus row 3, and when I do that, I'll replace the third row with that addition, and that's going to give me a new equation down here with hopefully y eliminated. That's kind of our goal. So my first two equations are going to be exactly the same. So I'm still going to have -3x minus 5y plus 36z equals 10. That's the same exact thing. That will not change. My second equation will also be the same. I'm still going to have -x plus 7z equals 5. And you'll notice I keep everything lined up as I go. That's kind of a good way to help yourself stay organized when you do these problems. And now I'll go ahead. -3 and 5x will be 2x. -5 and 5y will be 0. That will cancel out. That will go away, which is what I wanted. And then 36 and -50 will be -14z. And over here, 10 and -20 will be -10. So now that I have those y's eliminated, now I want to look for another variable to get rid of. Now, a little piece of advice that I gave in the last video, and if you come to the, or if you came to or come to, depending on when you watch this, the Zoom meeting that we're going to be having on Wednesday at 1:15, I'll probably repeat this advice a lot. But when you're trying to eliminate a variable, you only want to use equations that have the same variable. So for example, if I want to get rid of either x or z, I only really want to be using these two equations. This one also still has y there, so if I use it to eliminate, y is going to re-show up, basically meaning I didn't do anything. So I'm going to look at these two equations and kind of pick one to get rid of. I'll pick to get rid of x. You might already notice what's going to happen here, but we'll kind of go through the steps here. So to get rid of the x, let's say in this last equation, I'm going to multiply this one by 2. So we'll do 2 times row 2, and what that's going to do is it'll make all these be -2x, 14z, and 10, and then I can go ahead and add these together and make those cancel out. Once again, I'm going to pause the video for a second, and then you'll kind of zoom into the future with what these equations will look like at that point. So another jump into the future here. So just as a reminder, I know you just probably saw this 5 seconds ago, but we multiplied this row by 2. So now we have 2x plus 14z equals 10. And now we're going to add row 2 and row 3 together with the idea that we're going to be eliminating x so that we have a new equation. But there's going to be some unforeseen consequences here, okay? In the beginning, I told you guys this is going to be an example of when you have infinite or no solutions, and that is because all of our variables are going to disappear. If you notice, -2 and 2, well, yeah, that's going to give me 0x, and I technically already have a 0y, right, because there's no y there. But unfortunately, or fortunately, depending on how you're looking at it, 14z and -14z, those are also going to go away and give me 0, basically making this whole equation almost disappear. Now, here's kind of where the moment of truth happens as terms of whether this is a infinite solutions or a no solution problem. Depends on what happens on the other side. When I have 0x, 0y, and 0z, what should that equal? Well, if I have infinite solutions, it should equal 0. If I have nothing over here, I should have nothing over here. If it's no solutions, these are ones that do not have any solutions or no place where they're going to intersect. That would be a different number over here, basically saying that, hey, 0 equals some number, and that's not true, meaning we have no solution. So let's go ahead and let's take a look what would happen if I add these two together. 10 and negative 10, when I add together, I'm going to end up getting 0. So this is going to be an example of infinite solutions, okay? Infinite solutions. And you can say that in a whole bunch of different ways. You can write infinite solutions. You can say there's no unique solution. There's a lot of different ways to kind of say that. And if you remember in the last video, I said that this is conceptually what we're talking about are three-dimensional lines. So you're used to doing solving these systems of equations with two-dimensional lines, and it's where do they intersect. And these are looking at three-dimensional lines. We're saying where do the three-dimensional lines intersect. So if you can think about it, it's kind of almost like the walls in your room. If you kind of look at the walls in your room, so if I kind of look at that corner back there, right? So I have two walls and a ceiling, and the place where the solution is kind of the corner. Where do all three of those walls touch each other? Well, they all kind of meet at the corner, and that's the point that I'm finding that's the solution. Well, if two of my things I'm looking at in my equation, two of my lines, are actually the same wall, there's infinite places where they're going to touch. It's going to be the entire crease on the top-hand line, that whole crease where the ceiling and the wall meet. So therefore, I'm going to have infinite places that those meet, as opposed to when they're all different. If I have no solutions, that would be like three walls that never touch each other. So, for example, they'd almost be sort of parallel in the 3D space where they're all kind of going, and there's never a spot where all three of them touch. So that's kind of what we're looking at here, and that's kind of what we're looking for when we're solving these. Either we have infinite solutions, or if you get a number over here, that'd be no solutions. And really, it's the same exact style and the same exact process that you were doing with the previous problems. It's just kind of something different that'll happen at the end. If anything, it's kind of less work when you see this happen. You don't have to do the back substitution. Just kind of stop and say, all right, I have infinite solutions or no solutions. Thank you for watching. Just as a reminder, you need to finish the 4 problems that I told you to skip on the last section. That's what you're supposed to finish. So basically by the end of this week, in terms of holistically what we've done on the online classroom, you should have your project turned into me. I think I have just about everybody's for that. And you should have all the problems of the worksheet that I assigned finished. That includes the ones that have one solution that we were looking at before, and then the 4 that you were supposed to skip that'll have infinite or no solutions. Thank you for watching, and I hope you guys are doing well.